me start the screen sharing. Yeah, so I hope that you can see the screen.
Yes, sir.
Okay.
Yes, sir.
Okay. So as you know that I'm going to cover microeconomics in this semester. This paper will be shared with SM. Well, if you look at the course that is given in the website, uh, if I recall correctly, there's an error in it. Um, Module 1, 3 modules are shown. Module 1 is, I think, welfare economics and Pareto optimality. Module 2 is oligopoly, and module 3 is comprises of market failures. Well, actually, it's a wrong positioning. I'll be covering module 1 and 3, but the syllabus should be corrected, and sequentially the topic should come. Oligopoly should be the first module, and then we should have welfare economics and market failures. Okay. Now, first I want to discuss the module in details. So we have two modules. In my part, I've got two modules. One is welfare maximization, and the other is market failures. But the module on market failures I normally divide into two parts. One is the so-called traditional market failures, and the other is the information-related market failures. Okay. Now, in welfare maximization, we will begin by focusing on the problem of maximizing social welfare. In microeconomics, so far, what we have done is focus on a single agent, either an individual or a household or a firm. At the most, we have moved up to markets. But now we are going to cover the entire economy. So we are looking at producers, we are looking at consumers. The households now have a dual entity. They supply inputs but consume output. The firms also have a dual entity. They purchase the inputs from the households and supply outputs in the commodity markets. So in this situation, how do we maximize the social welfare of all the agents, all the different types of agents in the economy? Now, the old welfare economics, by old welfare economics, we are referring to that of Pigo and others, uh, or even earlier, Bentham, for instance. The focus, one of the assumptions was that interpersonal utility comparisons could be possible. So that means I can compare your utility with my utility and see that, okay, I'm getting 5 units of utility, you're getting 2 units of utility, so I'm better off than you are. For policy making also, this becomes very easy. Suppose there's a policy change, and as a result of this policy change, I gain by 10 units, but you lose by 15 units. So again, we can just compare them and say that, okay, the total loss to society is -5. This is somewhat simplistic. We can also add weights to it. But anyway, the basic assumption was that the utility of different persons could be compared. Lord Robbins criticized this old welfare economics. He pointed out that when you're making interpersonal utility comparisons, you're making your analysis subjective. So then the question is that, is it possible to develop a theory of welfare without making interpersonal utility comparisons? And so the problem shifted backwards to the works of Wilfredo Pareto. in the 1880s. So Pareto had offered the concept of Pareto Optimality, in which you can compare between different states, social states, without bringing in or without assuming interpersonal utility comparisons. So he defined Pareto Optimality, he stated some conditions, and we are going to derive the conditions graphically and mathematically. But we will show that Pareto Optimality results in a partial ordering. Okay, so what is a partial ordering? Well, before that, what is the opposite of this? What is complete ordering? Complete ordering is that you are given some possible states. You have learned consumer theory. So in consumer theory, you are given different commodity bundles and you can rank them. So if you are at a particular, you are consuming a particular bundle, you can divide the other commodity bundles into 3 sets. One set is better than your current states. The other group of commodity bundles will give you less utility than what you are getting now. And there's a third set where you will get the same utility. So you are indifferent between these commodity bundles. This is a complete ordering. So that means you can rank different commodity bundles as better than, worse than, and equivalent. In case of partial ordering, you can rank some bundles as better than, worse than, some bundles may be equivalent. But now comes the crunch. There are some bundles or some points or some states which cannot be compared. So you cannot, by looking at them, by comparing them, you cannot say that this is better or this is worse or whether it is equivalent or not. Okay, this is partial ordering. So the ranking better, equivalent, less is not possible. You have gray zones where you cannot rank the bundles. They may be better, they may be worse, you don't know. So in order to solve this limitation of Paretian theory, okay. So in order to take care of this limitation, we have to bring in the concept of a welfare function. And one of the common welfare functions that is used is the Bergson type welfare function. But again, when you bring in welfare, you have to bring in some notion of interpersonal utility comparisons. Okay. So what Calder and Hicks did, Lord Calder and Sir John Hicks did was, they tried to find out a criteria by which we could compare between 2 points or 2 states, 2 equilibriums. So you have a policy change, and that policy change will lead you from point X to point Y. Is it possible to say when X is better, the original state is better, and when the new state that occurs after the policy change is made, that is better? So can we compare X and Y? And it showed that under certain circumstances, based on a theory of exchange and compensation, it is possible to compare between positions, equilibriums. Then Tibor Skitowski came and he showed that we could have a situation when we start off from X and we have a policy change which leads us to Y. So we can have a situation when Y is better. So in that case, the policy should be introduced and we will move from X to Y. Then what happens is, this is why it's called a paradox. If you compare between Y and X, the effect of removing the policy, you will see that X becomes better than Y. Okay.
Sir, does partial ordering mean something like lexicographic
No, no, no.
preference?
No, in lexicographic, let's see what it was. It was better than. No, in lexicographic, it was the treasure island, right? So this is cheese and this is any other commodity X. So if you have more cheese, these are all better. If you increase consumption of X, that is also better. So instead of an indifference curve, you have points. Okay, but you can rank all of them. What happens is, in this case, you only have better points and worse point. You don't have any indifference points. So you cannot find out X and Y, 2 points between which you are indifferent. Okay, indifference curve means X and Y are 2 points, you are indifferent between them. So this possibility is ruled out. You either have XPY or you have YPX. Okay. Normally what we have is either XPY or YPX or XIY. We have 3 categories. Instead, in case of lexicographic, you have 2 categories. And in case of partial ordering, you have 3 categories: YPX, XPY, XIY, and you don't know which is better and which is worse. In XIY, you are seeing that they are equivalent, they are same. But here you are seeing that, look, I don't know which is better, which is not the same as XIY. So these two are not the same. Okay. So as I was saying, in the Skitowski paradox, what happens is, if you start from X, it is better if you go to Y. But once you reach Y, it is better if you come back to X. So that means you really don't know which is better. X is better or Y is better. And so the Kaldor-Hicks criteria had to be modified slightly. Then see, the main problem over here is that we are trying to address over here is how to maximize social welfare and what are the means of doing so. Here, in case of the fundamental theorems, you have 2 theorems. Theorem 1 states that, look, you have people who are extremely selfish. They are concerned with only their own utility and they are prepared to fight for it. So you have a cutthroat situation. I'm fighting against you, you are fighting against me, we are fighting against everyone in the class. So it's a big fight that is going on. In this situation, is it possible that we have such a group of cutthroat, selfish people? Is it possible to maximize, to coordinate your activities and maximize welfare? And the answer is yes. If you have a market situation, if you have a market and you have a price system, then this will automatically ensure, it will ensure that the activities of all selfish people are coordinated and social welfare is maximized. Now, when we are maximizing social welfare, it is quite possible that there are some people who don't have adequate purchasing power and therefore the market will not give their utility any weightage. So in other words, depending on the inequality in initial inequalities, you might end up at a situation where you maximize welfare, but the equilibrium is highly inequitable. So you have inequity. What to do in that case? And the second fundamental theorem shows that don't worry, there's no need for government intervention. You can still ensure that you can simultaneously ensure that you maximize welfare and the solution is equitable.
So can you repeat point 2 once again?
Yeah. What we are seeing over here is that look, uh, we start from a position where there's a given endowment of labor, capital, income, and so on. Okay. Let us suppose that the initial distribution of resources is unequal. So there are some people who have very little resources. There are other people who have command over a huge stock of resources, lots of labor, lots of capital. In that case, even though welfare is maximized, the resultant equilibrium can be highly inequitable. So in other words, although social welfare is maximized, those people who are poor enjoy very little utility. Those people who are rich have a lot of utility. Okay, so obviously this situation is not desirable. But the second fundamental theorem assures us that there's nothing to worry about. There's no need for earth-shaking government interventions. It is possible very simply to ensure that simultaneously we can both maximize welfare and the resultant equilibrium is also equitable. We have to have some notion of equitable. What we mean by equitable, we can ensure that the resultant equilibrium conforms to a notion, a concept of equity. So basically the fundamental theorems are saying that there is no need for government intervention. The markets are sufficient. They can ensure both efficiency, welfare maximization, and equity. So what happens to socialism? I mean, remember that these theories were coming up when the Russian economy was, when the Bolshevik experiment was being undertaken in Russia. So does it mean that socialism becomes irrelevant? So here we had the theorem, a theorem called the Lang-Lerner theorem, in which Oscar Lang and Abba P. Lerner shows that the markets can ensure welfare inequity, but it is also possible under a certain type of socialism to arrive at the same solution. Okay. Now, the assumption that, see, the results that we derive in this module are based on certain assumptions. They give very good results which are very assuring. They tell us that a market is an excellent mechanism. It can solve all problems, but we are making certain assumptions. And these assumptions are highly restrictive. When they fail, when these assumptions do not hold, then we have what is called market failures. Now the market failures can be divided into two parts. One is, as I've said, the so-called traditional market failures. The main types of market failures are externalities and public goods. So this is what we are going to cover in the second module. And the other relates to information related market failures. These stem from the works of Williamson, Akerlof. Stiglitz has also done some work, Diamond. So all these people have developed models to study markets where the information is not symmetric. See, the problem with the first module is that we assume that markets, or rather all the agents, have perfect informations. So they know that, okay, if I do something, I'm going to get a payoff. This is the payoff I'm going to get. Now I can introduce uncertainty. Uncertainty means that if I undertake some action, I'm not sure what the payoff will be. So let us say I've got two payoffs, pi 1 and pi 2, and associated with each of them we have a probability vector. So the probability that I'm going to get a payoff of pi 1 is p1. The probability that I'll get pi 2 is p2. So here we have some problem. We can also have situations where both producers and consumers do not have complete information. So in all these situations, we have a situation, all these situations describe a market where all types of agents are equally placed in terms of information. Information asymmetry is a case when, let us say, producers have more information than consumers. Okay, it can be the reverse also. Consumers have more information, producers have less information. So what happens is, in these cases, all persons are equally handicapped. In case of asymmetry, you have only one group of agents who are handicapped, and the other group can exploit this situation. So the market will break down, you will not be able to maximize welfare. There are possible situations: signaling, pooling, separating, equilibrium, cheap talk. You can have warranties, self-enforcing contracts. But the problem is that all these possible solutions have costs associated with them. And so it's not very easy to adopt them as costs. Okay. So far as the books to cover them, welfare maximization,
So could you show the previous slide?
this one,
Yes, sir.
with the writing.
Yes, sir.
Okay, which part? What I've written over here or here?
Yes, sir.
Okay,
Like
okay,
the
okay, I'll write it.
uncertainty.
So can you explain that uncertainty portion once again? Is that holding under the assumption that agents have perfect competition? Sorry, perfect information.
Okay, let me see it. Um, Okay, so this is the assumption that we have made in the first module. What it means is that you have a set of possible actions and you have outcomes. Okay, so if you take action, let us say action 1, action 2, action 3, you have possible outcomes. But if you see, this is a one-to-one relation. Okay. So if you know what is O1, O2, O3, you can choose between the actions in order to maximize your payoff. Right? You simply have to find out the ranking of O1, O2, O3. Let us suppose we have this ranking. So which action should you choose?
So O3. So we choose action 3.
Yeah. That is the best decision that you can make. Okay. Let us suppose, let's take an example that you go to the second hand market, you want to buy a car, and you go to the second hand market. In fact, let's not take this. Let's take a different example. Let's say that you go to the fruits market. You want to buy some oranges and you go to the fruit market. And you have to choose between the different fruits, obviously without tasting them. You want to buy 12 oranges. And the supplier gives you a box of oranges. So how will you choose them? I mean, is it possible for you? I mean, do you
No.
have perfect information?
So no.
So you will use some criteria like the skin should be wrinkled or whatever, it should be tight, it should be orange. You'll use some criteria, but the problem is that you lack perfect information. Okay, so you will choose 12 oranges. They may turn out to be good, some of them may turn out to be bad also. So in this situation, we often ask the vendor to help you out. Is it possible for the vendor to make the best choice? Well, he has more experience than you, but even he, without tasting, it's not possible for him also to identify the 12 best oranges. So both the consumer and the supplier doesn't have perfect information. So if you will choose 12 oranges, they may turn out to be good or bad. If the supplier chooses, then also you may not get the best 12 oranges. Right. Now the problem over here is that, or rather the good thing about this is that both the consumer and supplier lacks the information. Okay. One case is when we introduce uncertainty. So let us say I have got A1 But if I choose A2, then also these are the probabilities. So I know that O2 is better than O1. But how will I choose in this case? If I choose A1 and it turns out to be that this situation occurs, then my decision was wrong. Okay, so it's not really possible for me to choose in this case. But again, no one knows what is going to happen, whether it is going to rain or whether it is going to be sunny. So again, both the consumer and supplier are at a disadvantage, and therefore it's not possible for any of them to trick the others or cheat the others.
Sir, but the disadvantage is also asymmetrical. Means the supplier may also know that these oranges are sour, so he knows.
Yeah, if you go to Nagpur, what can happen is they will come to you at the station and they will sell you a box. The top of the box you have very good oranges, at the bottom you have all the rotten oranges. Okay, but see, I mean, if you are fairly beyond the point, is it possible to trick you? I mean, can he sell you very bad oranges, which you will accept blindly? Or let us suppose he's an honest vendor. Okay, so he doesn't want to trick you. You have been buying from him for a long period of time. Is it possible for him to choose the best 12 oranges?
No, sir.
But only if you can taste the orange, only in that case, it's possible to identify which are the 12 best oranges out of the box. So if you go to an honest vendor, even he will not be able to help you out. Okay. When you're talking about information asymmetry, let's consider second hand cars. Okay. Now, the person who is selling the car, he has been using the car for quite some time, so he knows the quality. But the person who is buying the car, does he know the quality? I mean, he goes to the second hand market and he sees a car that has been newly painted. He can go for a small drive also. But is it possible for him to know whether the car is good or not, or bad? I mean, for instance, when we sold our last car, it was turning out to be very, I don't know, it had developed a habit of stopping suddenly in the middle of the road, and it simply wouldn't budge. The good thing was that this used to happen once or twice a day. So if you drove the car for 1 hour or even 2 hours, the chances are very likely that you would not face the problem. Otherwise, the car was excellent. So you come to me and you want to buy the car, I'll say, okay, you go and drive about for 2 hours. You'll drive about for 2 hours, you will see that the car is functioning perfectly, and you buy the car. But what happens? The car has a major defect of stopping suddenly. Okay, Okay, so this is a situation when you have information asymmetry. One person knows the quality. In the second case, the consumer doesn't know the quality. So here you have information asymmetry. One party has more information. In case of the fruit market also, you can justify the same thing, that the fruit seller has got more experience than you. But why I don't want to bring fruits into information asymmetry is that even the fruit seller cannot say, I mean, he can say that, okay, these fruits are very bad and these are rotten. But he cannot say that, okay, out of the remaining fruits, he cannot rank all of them. Okay, so he also doesn't have perfect information. But in case of cars, for instance, well, the seller knows what the actual real quality of the car is. So in this case, we have information symmetry. When you are going to buy the car, you know this. You know that it is possible for the seller to trick you. And in that case, you will be a bit reluctant to enter the market. Okay, so we can have different types of situations like this: before the contract, after the contract, and you have possible solutions, but each of the solutions will have some costs associated with them. Okay. Okay. So far, so as I've said that if you look at the references, well, the bad news is that if I come to the can you hear me?
Yes, sir.
Okay.
Yes, sir.
Okay, because I'm having a bit of a problem. Anyway, so as I was saying that about the references, the problem is that in the first lecture, in fact, for most of this, I'm not teaching from any particular book. I will refer you to some papers or books in some cases, like in Pareto Optimality, for instance. There's a paper by Francis Bator in Quarterly Journal of Economics. But that's all. In externalities, again, when I'm looking at the modern definition of externalities, I'm going to refer to a paper by Buchanan and Stubblebine, Economic Journal 1961. Public goods,
So will you return to these slides again, like the traditional market failures and the information failures?
return in what sense? This is just a course. So I'll give you I'll have to discuss what these are.
Yes, sir.
Public goods, there are several books. The best book is, of course, by Lindahl. Sorry, not Lindahl, Johansson, Public Economics, which is available in our library. So that should be available. Information related market failures, I'm going to cover mostly from Perloff's Microeconomics. So I will give you some references, but don't remember whether it is 60 or 61.
Sir, so this is just a rundown of the course structure, right?
Yes,
We'll be
yes.
again. Again.
So this is Perloff's Microeconomics. That is the Lindahl model. This is externalities. This was this is Pareto Optimality. So this is the reference. Let us see. Okay. So I'll repeat the references when I will cover the specific course. Okay, so let us start with welfare maximization. I will not go into the too much technicalities. Now let us consider a society of n persons, okay, and each of them has a utility given by ui. So that means the first person, whom we label as 1, has got a utility of u1, the second person has a utility of u2, and so on up till un. Now how do we calculate social welfare for this? I mean, if you want to maximize social welfare, then you need to get an estimate of the social welfare, right? Now Bentham argued that you can simply add up the utility of different persons. So social welfare is u1 plus u2 plus u3 so on up to un, summation of ui. Okay, so that means if you have two persons and your utility is 5 and 10, u1 is 5, u2 is 10, then the utility welfare is simply 15. If your welfare is 6 and 8, you get a welfare of 40. Okay. So in this case, I'm giving some states, let us say S1 and S2. You have got two possible equilibriums. U1 is 5, U2 is okay. In which state is social welfare maximized?
So state 2.
What is the welfare in this case?
So first case 15.
15.
And second case?
14.
So why is welfare maximized over here?
So because it's more equitable.
No, but we are trying to maximize social welfare. What is our objective? Maximize W.
So then it's state 1.
So maximize W implies that S1 is preferred to S2. But as you have said, there is a problem with S1. It is not equitable. So instead of taking the Benthamite welfare function, can we take the Rossian welfare function? The Rossian, this is named after the philosopher John Rawls. It says that you have to look at all the utilities of different individuals, and welfare is simply the minimum of all the utilities. So if you come over here, you have got two individuals again, 5 and 7. What is the welfare in that case?
Five.
Okay, here 8 and 7.
7.
In this case, it is an equitable situation. Both are getting 9. So that means your welfare is 9. So if you go back to our original example, if we use the Rossian welfare function, let me label this as WB. So this is a Benthamite utility. If I take the Rossian function WR, what is the welfare in this case? 5 and 10.
So 5.
And in this case, what is the welfare?
So 8.
Is it 8?
So 6.
6 to 6.
6.
Okay. So if I try to maximize welfare, what will I choose?
So state 2.
State 2 is preferred to S1. Now you can think of it in this way, that welfare is I'm taking two individuals just for convenience. This is a weighted average of the utilities. Okay. Now, when I'm taking the weighted average, in case of Bentham, what are the weights? What is the value of alpha 1 and alpha 2 in case of Bentham?
So 1.
Yeah. So alpha 1 is equal to alpha 2 is equal to 1. They've got equal weightage. In fact, what we normally do is, it's not actually 1, it's, you can see it's 0.5. Because remember, alpha 1 plus alpha 2, the summation of weights should equal to 1. Okay, you can check that your conclusions are not really affected. Okay, what is the weighted sum of this? You have to take half, right? So this is 2.5 and this is 10, it's 5. So it's 7.5. In the second case, you have to add 4 and 3. So it's 7. So which is better? Again, S1 is preferred to S2. Okay, so as long as the weights are similar, it doesn't matter what the weights are. So that is why you should take 0.5. Okay, but if you are taking Rossian welfare function, what are the weights? So here we have to identify the poorest person. Let us say it is alpha 1. Then alpha 1 is equal to 1, alpha 2 is equal to 0. Okay. If alpha 2 is the poorer person, what will be the weights?
Alpha 1 0, alpha 2 1.
Exactly. So we can think of welfare as the weighted sum of these two individuals, of the n individuals in society. Okay. So in the general case, if I've got n number of persons, I can write So basically what Bentham, Rawls are doing, they are setting, they are weighting people differently. Now, which of them is better? What do you think? Which of them is better?
Sir, the Rossian one.
Why?
Sir, because it is theory of veil of ignorance. We can think of if we are that person, then what means impartial view.
How does the wheel of ignorance come into this analysis?
Sir, means say means the income of means we should be thinking of the state of the poorest person because say, that would be moving to a more egalitarian system.
Okay, so you're arguing that people we should try to aim for egalitarianism, and this will give us more. This should lead us to a Rossian, prefer the Rossian type of utility function. Okay. Now look at the distribution over here, 4, 6 and 5, 5. So we have got two individuals, A and B. In the first case, A gets 4 and B gets 6. In the second case, both of them get equal amounts of 5. Can you tell me which is better? Obviously, the first state is unequal. The second state is perfectly egalitarian. Would you prefer?
So in terms of welfare, both are equivalent, but since the second one is more equitable, we can say that is better for the people. Like,
Okay, so you object to the fact that B is getting more utility in the first case.
yes, sir.
But suppose B is challenged in some way. B is a handicapped person.
Sir, then we are arguing on the definition of poor. Sir, what we meant by poor. Sir, poor in monetary sense or poor in physically
Yeah,
handicapped. Means what we are.
yeah. So if B is, let us say, physically challenged or mentally challenged, should we not give B some additional resources to compensate him or her? Is it unfair?
So on a principle basis, no, it is not unfair.
But you don't seem to be very convinced.
Yes, because like in reality, it never happens
No, no, what I'm
that.
saying, I'm not saying what happens in reality. Suppose you are the um, head of the state. Which one would you choose if you know that B is challenged?
So then probably I'll choose the first.
Sir, usually the states provide means resources until they reach an equal level. Sir, after that means it's up to that individual. Means I don't think so. The state should look to make it even better off than individual. Means, if they're already equal, why should I make them better off without making someone worse off?
Yeah, what do the others have to say about this?
So Yeah, I'll choose the 4-6 then.
No, do you agree with Owen?
No, I'll choose the first distribution there. Uh, just to give the people like a equal stance because they're underprivileged or handicapped.
Okay. Let us consider a starting situation 10 and 2. What is wrong with this situation? It's highly inequitable, right? Now consider the four possible alternatives. Okay, 10, 8, 11, 7, 11, 8, 4, 2. Which one will you choose? And why? Look at 10, 2 and 10, 8. Which is better?
10 8.
An 8.
8.
Okay. So always the starting point is 10, 2. Okay. Okay. If the alternative is 11, 7.
So the difference is more. So
No,
10 it
10,
is
2
better.
and 11, 7.
Sir, 11 7.
11.
Okay. 11, 8.
11 8. 11 8.
4, 2. 4, 2.
So 10 2.
10 2.
10, 2. It's better. When you go to 4, 2, see what happens in these cases, in all the four cases. If you compare between 10, 2 and 10, 8, what is the difference? Has A's position changed?
No, sir. No, sir.
B has gone up. B is better off.
Yes, sir.
In the second case, both are better off. 11, 7, both are improving. B is improving a lot, but even A is gaining. The same thing holds for the third 11, 8 case. And in case of 4, 2, the fourth case, A is being worse off, B is remaining the same. So the choices are very easy in these two cases. Now look at this case, 4, 12 and 6, 6. Which of them is better off? Is the choice similar to the earlier situation?
So no.
What is happening is,
So one is in 412, one is worse off. Like the one who was previously better off is now worse off, and the one who was previously worse off is now better off.
yeah. So in the earlier case, you were keeping one person same and improving the other, or you were improving both of them. Here what is happening is, it's almost, you can say, it's some sort of a zero sum game, right? One person is gaining, the other person is losing. It's very difficult. The only thing about 6, 6 is it's equitable. But as I've said, B may be handicapped, he may be autistic, so it becomes a somewhat difficult situation. It's not always, 6, 6 does not always represent the perfect solution. Five, 7. So 4, 12, 6, 6, 5, 7. Which of them will you choose?
So 6 6.
Okay. 7, 5 and 6, 6.
So 6 6.
6 6.
Okay. Now suppose you ask your best friend. Okay, so let us suppose that you are person A and there's some other person who is B. Okay. Let us suppose that you ask your best friend to make the choice. Right? So that your best friend has to choose between the three possible equilibriums. What will your friend choose? 6657 or 75?
So 6, 6.
Why? He's your best friend, isn't he?
But sir, won't that be like a moral dilemma? Like considering B is handicapped and autistic.
No, it's not. Forget about handicapped. Just see, you've got three perfectly normal people. It's 6657 75.
7, 5. Then 7, 5.
75. Okay. So B gets very angry. Second time, he removes your friend and he installs his friend to be the judge. So what is this new judge going to do? 5-7. 5-7. See, what we are trying to do is, we have possible cases, and which situation is better off depends upon the outlook of the person. When we are looking at 5-7 or 7-5, for instance, who the judge was, whether it was A's best friend or whether it was B's best friend who was making the decision. If you're looking at the handicapped or autistic case, you either can say that, okay, this person is challenged and it deserves some compensation, or you can take Owen's stance. If Owen was the policymaker, then his logic is that I'm going to provide a certain amount of equal resources, and after that it's up to you. So depending upon your outlook, the answer to what is the best state is going to differ. We don't have any uniform or unique answer. What is important is the outlook of the person who is taking the decision. In other words, decision making becomes highly subjective. Okay, is it clear? So basically what wrong? Yeah.
Sir, could you show the previous slide, like slide before this one?
So then the only quote unquote correct choices are when both are like being improved, like 11 and 8. Like those choices.
Or both of them are becoming worse off, you don't choose that equilibrium.
So like those are the certain choices, and for the rest it depends on outlook.
Yes. Now, is it always possible to have such situations where both are being improved, or both are being worse off? That these are basically what we call trivial choices. You know what is better. Okay. The real situation, the difficult situation is when one person improves, the other loses. And once this situation comes up, basically what you have to do is you have to assign weights to the person. Okay. So when you see what you are doing over in these cases implicitly is, remember the 5-7 and 7-5 cases, See, in both of them, if you just sum the welfare, it is 12. But if you assign weights to the persons, if you compare the utilities of the persons, what you are basically seeing is that you start off from 6, 6. If you give one utility, you take away one utility from B and you give that utility to A. So let us say you start from here, and what you do is you give A one extra utility and B you take away his utility, right? This additional 1 unit is more important than this minus. That is what you are implicitly saying. You are saying that if A gains, that is more important to me because A is my best friend, right? Otherwise the plus 1 and minus 1 is simply going to get cancelled out. So you are basically assigning greater weightage to A. You are saying A is more important to me, B is less important to me. Do you understand what I am saying?
So that personal interest determines welfare.
No, what I am saying is that in this case, see, if I try to make decisions like this, it is going to be highly subjective, because remember that if I choose B's best friend, then what does it imply? What will he say? He will say that this is less important, A's gain, A is less important to me than B. So the fact that A is gaining is less important than the fact that B is losing. So we have one planner who says A is more important. We have got another planner who says B is more important. Okay. So when we are making the choice, who is the planner, that becomes extremely important. We are going to get different results as we move from one planner to another, as the outlook of the planner changes. I mean, suppose we start off with P1. P1 was initially A's friend. Then that planner and A quarrels. He becomes B's friend. What will happen? He will overturn his decision. His answer will differ. So is decision making robust if you are going to make such comparisons? If you are going to say that, look, I'm going to compare between A's gain and B's gain. It is going to become highly subjective. So this is what Robbins had argued. That if you are trying to base welfare, if you are trying to choose between different equilibriums based on comparing utility, this is going to be ad hoc and subjective. You will not have a scientific basis for your decision making.
So why don't we consider a planner who's indifferent between A and B?
Unbiased.
In that case, how will he choose between 7-5 and 5-7?
That's my question. How do you choose?
So basically what happens is that if you make interpersonal utility if you allow interpersonal utility comparisons, the advantage is that you can always choose between possible equilibrium. Right? But what is the disadvantage? The disadvantage is that your decision making will be ad hoc and subjective, not scientific.
Sir, but policy making is restricted to the government, so we should be only thinking from the side of government and not what interpersonal, what we think.
No, no, interpersonal utility comparison means it doesn't mean that you have you're friends with someone. What I'm saying is, if you compare between 7 and 5 and 5 and 7, right, you have to say, see, if you're choosing this, you're saying that A is more important to me. For some reason, I believe that A is more important. And in this case, you're saying that B is more important. It need not be on the basis of friendship. Maybe you believe that you have a particular outlook, and based on that outlook, you are going to either prefer A or B. Think of them as capitalists or labor. You believe that workers should get a good deal. That will lead to a particular type of decision making. But someone else believes that, okay, if you favor capitalists, then growth is going to go up in the long run, and the workers will also benefit. So in that case, your policy should be in favor of capitalists. I use the word friendship just as an example.
Yes, sir. Understood.
Okay, so if you make interpersonal comparisons, it's not possible, you're going to end up in trouble. A highly subjective decision making which is not robust. As soon as the situation changes, your output changes, the result is going to change. So then Pareto came up. Or rather, he was there already. Okay, if you compare 12 and 18 with 12 and 20, what is happening? B's utility is going up. A is same, B's utility is going up. 12, 18 and 16, 18, B's utility is same, A's utility is going up. Okay. In this case, the opposite is happening. One person's utility is remaining same, the other person's utility is going down. Right? So Pareto argued that if you keep the utility of one person constant and increase the utility of the other person, then this is a Pareto superior. The second equilibrium is Pareto superior. Okay. So here, these two are Pareto superior to the original equilibrium. And these two are Pareto inferior to the original equilibrium. Do you understand what is Pareto superior and Pareto inferior?
सर ना पैरेटो ऑप्टिमल था जानो सुपीरियर इंफीरियर है
Superior, what happens in this case? A's utility is constant.
So basically, A in the first case, A's utility is constant, but B is being like better off, and A is
Yeah.
also not worse off.
So in case of Pareto superior, no one loses. Okay, if you move from here to any of these states, is anyone losing?
No, sir.
But at least one person is gaining. Right? So what is Pareto inferior? No one gains,
But one loses.
at least one person will lose. Okay, so if I look at a 3-person case society, let us say 3, 12, and 6. What is a Pareto superior state? Right. So B will be indifferent, but A and B are both gaining. What is Pareto inferior? Can you give an example from here?
2, 10, 6.
So again, the third person is indifferent. He doesn't gain or lose. But now we find that the first two persons are losing. So this is Pareto inferior. Can you tell me what will be this? 2, 10, 4. I'm always comparing with this one. Okay, this is my reference point. Is this Pareto superior or inferior?
Sir, inferior.
All the persons are losing. Right. Okay. So, if no one loses, the utility of no person decreases, but utility of at least one person increases, we say that there has been a Pareto improvement. So given U1, U2 and Un, there is a change and society moves to V1, V2 and Vn. Pareto improvement implies that Vi is greater than equal to Ui, with Vi strictly being greater than Ui for at least one I. It can be more I's also. Or maybe all the persons are gaining. That's also possible. But no one should lose, at least one person should gain. Okay, so if this condition holds, then we say that V is Pareto superior to U. When can we say that V is Pareto inferior to U? Can you write out this condition?
Sir, it
Vi
is
is less than equals to Ui with Vi less than Ui for at least one I equals 1 to n.
So could you show the previous slide once? Thank you, sir.
Okay. So over here we can see that this person is losing. Here this person is losing. Okay.
Sir, I have a question here.
Yes, yes. Prithviraj.
Sir, yes, sir. So here we are showing that Vi is greater than equal to Ui. It is a weak inequality. But sir, then
কোনটে?
how can we sir, Pareto improvement এর ওখানে?
আচ্ছা ওই লাইনটা, হ্যাঁ। vi is greater than equal to ui.
So
হ্যাঁ,
in such strict inequality, Vi greater than Ui. Sir, আমরা strict আর weak inequality simultaneously কি করে show করতে পারছি?
আচ্ছা, see, vi greater than equal to ui means that you can have two possibilities. Either vi is আচ্ছা ঠিক আছে, এইখানটা since you are having a problem, ঠিক আছে, let us suppose this is u and this is v. So how many i's do we have? I ranges from 1 to 5. আচ্ছা, আচ্ছা, what, sorry, এটা 2 হবে. So what is the relation between u1 and v1?
So equal.
u2 and v2?
So equal up till U4 is equal to V4.
তারপরে
Less than.
আচ্ছা, তাহলে তোমাকে পাঁচটা, you have to write, you are writing on 5 conditions. How will you write this? Based on this information, how will you write this?
Less than equal to.
ঠিক আছে?
হ্যাঁ স্যার বুঝতে পেরেছি এবার।
Sir, I have a doubt.
Yes.
Could you go to that this slide? Yes. So then, sir, 2, 10, 4. In this case, none
Where-
of them are like
2,
Uh,
10,
4.
Huh.
When we are comparing it with 3, 12, 6,
hmm.
then in that case it will be just less than, right?
Right, huh?
Vi
Okay,
is,
fine. But
so in that case also there'll be Pareto like
Yeah.
inferior.
yeah, see, if I say that ui is less than equal to vi, let us say, what does it mean for a particular u1 and v1? What I'm basically saying is that this is ruled out. ঠিক আছে? We can have two situations. Both are possible. Any of them are possible. But this is ruled out. That is what I'm simply saying.
Okay, sir, got it.
So it is not. So Pareto then said that when do you reach a Pareto optimal state? See, in this case, for instance, when you're moving from U to V, you're gaining, right? You're having a Paretian improvement. V is Pareto superior. When are you at a Pareto optimal state? When you can improve the utility of one person only by reducing the utility of another person. Look at this case. 10, 10. Is the first person gaining?
No.
No, sir.
5, 5.
No, sir.
Okay. 2, 4.
He's
Yeah.
losing.
He's gaining.
He's gaining. So I equal to 3 is gaining, right?
Yes, sir.
But what has happened to 4 and 4? The fourth person.
He's losing.
Losing.
So 3 gains. But this is because the fourth person loses. Okay. So this means the original equilibrium, this one, 10, 5, 2, 8, this is a Pareto optimal equilibrium. We can improve the utility of one person, in this case the third person, only by adversely affecting another person, which is the fourth person. See, we are not making any interpersonal utility comparisons. 3 is gaining by 2 units. The fourth person is losing by 1 unit. But we are not comparing between them. We are simply looking at the gain or loss. We are not comparing the magnitudes.
Sir, then what are we saying between these two situations that we cannot compare?
Yeah, we cannot compare. That is why we are saying that Pareto gives a partial ordering. If you start from 10, 5, 4, 7 and move to 10, 5, 2, 8, so you are going back, which is better? The third person is losing now and the fourth person is gaining. So again you cannot say which is better. Now you will say that 10, 5, 4, 7 is a Pareto optimal equilibrium. Okay. So, if I am comparing between two states, U1, UN and V1, Vn, how do I mathematically define Pareto? Say that U is Pareto optimal.
Sir, if ui is less than vi for some I and uj is greater than vj for something like that.
No. Can we write in this way? ui is less than vi with uj greater than vj for at least 1j. See whether it is satisfied. 10 10, is this condition satisfied? Yeah, it is satisfied as an equality. ui is equal to vi. 5 5, again u2 is equal to v2. So this is satisfied. Come to the fourth person. Come to the third person. 3. ui is 2, vi is 4. So now ui is less than equal to vi. Okay. Come to the fourth person. uj less than equal to uj is greater than equal to vj. This holds for the fourth person. In fact, we should change this definition slightly, make it a strict utility. Let me write this separately, it's getting clogged up.
Sir, can you please show the last slide once? So, okay, sir, yes.
Okay, let us look at it. Let us say u is and v is 10 5. The third person gains. Let us say this is 6. The fourth person loses. Okay. So u is Pareto optimal so for some I
Sir, uj.
yeah uj for at least 1j I not is equal to j. Okay, so if one person is gaining, you should have at least one person who is losing. Then you say it is Pareto optimal. Okay. That's it. So I'll stop at this point.
So could you just show the last slide again, please?
This one.
Yes, sir. Thank you.
Yeah. So in this case, you can see that U3 is less than V3, but U4 is greater than V4. And for the remaining cases, you have for U1 and U2, these are equal. Okay, in the next class, we are going to take a 2 into 2 into 2 models. So it means that we are going to take two inputs, labor and capital. They are used to produce two commodities, X and Y. These commodities will be consumed by A and B, who are the two consumers. We assume that we have fixed amounts of endowments of labor and capital. The technology is given. It is manifested in two production functions. X is a production function is given. We have to use Lx and Kx, and Y we are using Ly, Ky. Okay. So remember that L bar is equal to Lx plus Ly. This is equal to so if I am increasing Lx, Ly has to fall. If I increase Ly, Lx has to fall. Okay. In case of X, X is also distributed between the two consumers. Suppose I want to increase this. Will Xa have to fall? So here we
Yes.
can see that Lx increase implies Ly fall. Okay, but here if Xb increases, does Xa have to fall?
Yes, sir.
Why? Can we increase labor and capital? Can we reallocate labor and capital from Y to X? In that case, what will happen?
So are X and Y like two types of producing, like two different
X and Y
technologies?
are two commodities.
Okay, sir. Exactly.
So suppose we reallocate labor and capital from Y industry to X industry. In that case, what will happen? X is going to go up, right? So keeping A constant, we can increase X so that B can consume more. Okay, so this is the difference between inputs and output. But look, this also has a cost, because in that case the production of Y has to go down. Okay, but functionally if I look at this equation, if I increase Lx, Ly has to fall. But here, so basically what I'm getting is an increase in Lx is equal to the reduction in Ly. But here, the increase in Xa is equal to, you simply increase the production of X. But note that Y will fall. Okay. So then we will show graphically, we'll first graphically show what is the equilibrium, what is the Pareto optimality conditions, and then we'll derive the conditions mathematically.
So can you show the last slide in Pareto Optimality once again?
This one?
No, sir, the one after this.
Excuse me, sir.
Okay, sir.
Yeah.
Sir, we did the entire consumer theory, sir, keeping preferences as ordinal, sir. Sir, but here we are taking it as cardinal. We are adding equalizing.
See what you can think. See, I used utility just for as an example. Instead of that, um, you can simply assume that you have the commodities are known. You know how much you are consuming, and you know that A has more utility than B, or vice versa, but you don't know how much. So as you'll see when I'm when I'm saying giving values to utility, this was just to make you understand the situation. Okay, what I actually need is just this statement. I can say this ordinarily. I'm not saying how much, right?
Yes, sir.
In fact, if you look at this definition, the Pareto definition, when I'm giving a formal definition, I'm only comparing them. I'm not saying how much. Here also, I'm just saying this is greater than equal to. I'm not giving the values. Okay. Here I've just used examples so that you understand easily.
Yes, sir. Understood.